Okay, now with the background that we have, by solving the two parts of a logical puzzle in the previous video, we can now attempt to solve this question from the model question paper, right? So this says an island has two tribes of natives. So any native in the first tribe always tells the truth, and the other tribe always lies. So this is like the knight and the knave, right? So let us say like A and B, right? The two tribes are so this always tells the truth, and this tribe always tells the false. Now, you arrive at the island and ask a native if there is gold on the island, right? So the answer that you get is there is gold on the island if and only if I always tell the truth. So this is what that person says, and like if you remember in the previous question, the conclusion that we had to make was to determine if A kind of people A and B were, like whether A was a knight and B is a knight or B, like that. But in this question, the conclusion that we have to make is if there is gold on the island. So, if we want to convert this sentence into a propositional statement, the variables should be like we can take P as there is gold on the island, right? There is gold on the island. That's P, and Q is I always tell the truth. I always uh, tell the truth, and the conclusion that we are trying to make is if P is true, right? If P is true, then that means there is gold on the island. Now, if we convert this sentence into a propositional statement, right? This is a biconditional statement because we have if and only if, right? So there is gold on the island if and only if I always tell the truth. So this is how it looks, right? Now you know that for implication, an implication can be false when only when you have this, where the left side is true and the right side is false. That's when implication is false, right? But then, but when you have a backward and forward implication, like in this case, it will be false only when the two are different, which means this is for implication, and for double implication where you have p uh, forward and backward implies q. It will be false when both are different. Like if t is true and q is false, it will be false, and also if q is false and if p is false and q is true, it will be false again because it has to be going in both directions, right? Okay, so with that, if we again continue with our proof, now we again will do an assumption that the person that who's telling us this fact is A, which means he is telling the truth, right? If he is telling the truth, then this should be this should be true, right? This should be true. And also, if A is a person who is telling this, then Q will be true because he always tells the truth, right? So Q is true. Now, if Q is true, for this whole thing to be true, from the truth table, we know that uh, like it can be false only when the two are different, right? So this also has to be true, right? So uh, Ray is the person telling us we can conclude that there is gold on the island because P is true. Now let's say if it's not A, it's B, which means the person from the other tribe, which means he'll always lie, right? So it'll be not Q, right? Or this Q will be false. So if that's false, now if B is telling this, right, then if B is the person telling this, then P forward and backward implies Q should be false, right? Because whatever he says is false. So this whole thing should also be false. Now, since it's B who is telling this, we know that Q is false. And how can the whole thing be false? The whole thing can be false only when The two variables are of different truth values. Now Q is false, so then P has to be true for the whole thing to be false. So again, I can conclude, let's make the same conclusion, right? So which means whether it is A or B, we can always make the conclusion that there is gold on the island. So the answer is yes. Yes, there is gold on the island.